We are learning about rational numbers today. Your learning target, you are going to be able to evaluate and compare rational numbers. So, vocab. Rational numbers is any number that can be written as a fraction, but in math world we use the word quotient. So, any number that can be written as a quotient. Now check this out. I'm going to get technical here. Quotient A over B, quotient is a fraction, okay? Such that, that's what the dots are, such that A and B are integers, that means whole numbers and their opposites, okay? And B does not equal 0. Because you can't divide by 0. It's undefined. Your calculator will say, error, I don't even know what to do. Okay, so definition. Any number that can be written as a quotient, AB, such that A and B are integers, whole numbers and their opposites, and B does not equal 0. That means you can't have a decimal fraction. That means you can't have like 3.2 over 5.5. That is not a rational number, okay? That's not a rational number. A rational number is any integer, and integers are not defined as decimals, okay? So, equivalent fractions. To create equivalent fractions, we multiply or divide the numerator and denominator by the same thing or factor. So you multiply or divide the numerator and denominator by the same, I'm going to say, number. You could call it integer, number, factor, whatever you want. Lots of synonyms. Okay? So we're going to make some equivalent fractions quickly. This is a nice little break from yesterday. What are some equivalent fractions to 1/4? Natasha?
2/8.
2/8. What did you do to get 2/8?
Multiply them both by 2.
Sure. Multiply them both by 2. Griffin?
16 fourths.
16 what?
4 over 16.
Oh, 4/16. So 4 over 16. Multiplying the numerator and denominator by 4. Jaden?
25 over 100.
Nice. Timesing them by, whoops, I'll make that 100. Timesing them both by 25. Eric?
1 million over 4 million.
Oh, why not? 1 million, there's 6 zeros in a million, right? They do it. Over 4 million. Okay, that's not my favorite, but it's definitely equivalent. That's because it took so long. I like to create things as simple as I possibly can. I would have done 10/40ths. Okay, I would have definitely done that. I usually always do tens, and then I do doubles, and then I usually will do like a negative just to make it look fancy. Negative 10 over 35. Give me some equivalent fractions to that. Christian?
Negative 20 over 70.
Negative 20 over 70. Christian doubled it. Yes. Natasha?
Negative 5 over 7.
Nice. Thank you for choosing that one. You can definitely divide them both. Well, we got that off.
You'd have to cut.
We'd have to divide them both by 5, right? Negative 10 divided by 5 is a negative 2. Negative 2 over 7. Okay? Right? Because that is awesome. Because I love, so many kids think you have to multiply, but no, you can divide it out too. Jonathan?
100 over 350. Or
Negative 100 over 350, times them both by 10. Beautiful. Let's call her good. Now 2/3. Kyle?
346 over 519.
What?
What?
Okay, what did you do?
I multiplied by 173.
Okay.
How did you do?
Okay, why not? Why wouldn't you do that? Why not? 173 you multiplied them by?
Everybody
Austin?
4 over 6.
There we go, that's what I'm talking about. Emily?
20 over 38.
With the tens, keeping it simple. Do we have another unique one like Kyle's, Christian?
2 trillion over 3 trillion.
Okay. How many zeros is that?
9. Skip it.
Just do, you skip it.
Can I just do 200 over 300 and call it good?
No, half
zero.
a zero.
1, 2, 3, 4,
Just do
5,
three
6,
dots.
7, 8. I can't. Christian, I can't.
Just do 8. Just do 8.
2 to the 8.
That's plus. You guys made it.
You're just going even 20.
1, 2, 3, 4, 5, 6. I don't know. I don't even know if they're.
That's 100 million.
Yeah, sure. 20 million over 30 million. Works for me. All right. We are going to compare and order. Next target. Compare and order. We want to get a common denominator, then compare the numerators. When you compare and order, you want to get a common denominator. I'm going to abbreviate it, common denom, and then you compare the numerators. Now that's a technical way to do it. A lot of kids in your grade like to use logic, like to try to benchmark a fraction, like how far is it from its whole? Is it over halfway to the whole? Which whole is bigger? I'll model both ways, but the logic method you can mess up pretty easy. So I want to make sure to show you the technical way. Also, I need you to know that the bigger the negative, the smaller it is. The bigger the negative, smaller the number. Okay, so I'm going to order negative half, negative 4/10, negative 2, and 0.9. What is 0.9 as a fraction? What is it? Just tell me.
9
9/10. So I'm going to rewrite that as 9/10. I guess I don't want to X that out because you always have to go back to the original. You have to put it back the way you found it. It's just like if you go to someone's house, it's a respectful thing to put everything back the way it was before. Same way with math.
Wait, do we order?
So we're going to go from least to greatest. Yep, so I look here and I see that the common denominator would be 10. 10 is the best denominator to use. So I'm just going to get my equivalent fractions ready. Negative 4/10 is already in a 10. I don't need to do that. Negative 2, notice I'm putting it over 1. And then 0.9 is equal to 9 over 10. And now I'm just setting them up. So 2 times 5 is 10. Negative 1 times 5 is a negative 5. Okay? Negative 4/10 is already done. 1 times 10 is 10. Negative 2 times 10 is negative 20. And that one's already done. So now I'm looking for the biggest negative. The biggest negative is the smallest number. Negative 20, right? Negative 20, though, was given to me as negative 2. So I have to put negative 2 down. I have to put it the way I found it. Griff, what's the next biggest number?
Negative 5.
Negative 5. And how was negative 5 given to me?
Negative 1/2.
Yep, so I'm going to write negative 1/2. Okay, what's the next biggest number? Jake?
Negative 4/10.
Negative 4/10. And that was already given to me in its original form. And then lastly, 9/10, which was given to me as a 0.9. Okay? Yes, Jeff.
Why is the whole number first?
It's the biggest negative. The bigger the negative, the smaller it is. So that's why it's first. Okay, next one. 1/2, 1, negative 8/10, and negative 0.2. I'm going to use 10 as my denom again. So I'm just going to create equivalent fractions. That's already done, so I can leave this, and this is negative 2/10. That's me getting them alike, okay? 2 times 5 is 10, so 1 times 5 is 5. 1 times 10 is 10, 1 times 10 is 10, and there we go. So what's my biggest negative? Sarah? -8/10, and it was given to me as -8/10, so I would just write that down. -8/10. Okay, Eric, what's the next biggest?
-0.2.
-2 is the next one. It was given to me as -0.2. Yep. And then it's just kind of logic from there. 5 comes next. It was given to me as a half. And 10 comes after that, and it was given to me as 1. Okay? So let me just recap my strategy. When I put them in order, I found a common denominator, and then I created equivalent fractions and compared the numerators, always putting it back in the original form. All right, I'm going to skip this top one because we've done enough. And we need to compare, most of your assignment today is going to be about comparing two fractions. So this is where I'm going to model the logic thinking, and I'm going to do the traditional way. Traditional way is to get that common denominator. 35 is my common denominator, right? 5 times 7 is 35, 4 times 7 is 28. 7 times 5, 6 times 5 is 30. Which one is bigger? The 30, okay? That's the technical way. Logic, you always compare the numerator to the whole. The bottom is the whole. So the 4 is 1 away from the whole, and the 6 is 1 away from the whole. So they're both 1 away from the whole, so I can't really go much off of that. But which whole is bigger, a 5 or a 7? 7 is bigger, so that's going to be a bigger fraction. Okay? And 2/3 and 3/4. Following the logic strategy, how far away is 2 from its whole?
1.
How far away is 3 from its whole?
1.
So that didn't really help me much. Which whole is bigger, a 3 or a 4? 4 is bigger. Okay? The 4 whole is bigger. Now, logic gets tricky though. It gets tricky when you have like wholes that are like a situation like this C. 3 is only 1 away from the whole and 7 is 3 away, but yet 10 is way bigger than 4, so I mean that's where it gets a little tricky, where I like to use the normal method of finding that common denominator and comparing from there. Notice that 9/12 is barely bigger than 8/12. They're almost the same, slightly. And here I'm going to choose 40. We get -30 and -28. That is smaller, right? If you think about 3/4 is -0.75 and 7/10 is a -0.7, the bigger the negative, the smaller it is. Okay? All right, evaluating rationals. All you do is plug the number in and then simplify. Right now I want you to evaluate the A, B, and C, those 3 examples. We'll come back together in about 2 minutes. Okay, remember evaluate just means that you plug in and we simplify after we plug in. I spelled this wrong. It should be simplify. Okay? All right, evaluate for A is 6 and B is -5. So I put 6 and I put a -5 there. So 6 plus -5 over -3. 6 plus -5 is 1. That turns into 1 over -3. There we go. Done. 7 minus B. B is -5 over 3 times A, and A is 6. 7 minus B. Now this is where, remember, we use that parentheses. B is all of that. 7 minus a -5 all over 3 times 6. That's 7 plus 5 over 18. 7 plus 5 is 12 over 18. And divide them both by 6, you get a 2/3. Right? And last one. We turn that into 6 plus 9 over -5. 6 plus 9 over negative 5, 15 over negative